This spring, are you teaching 90 again?
I am teaching 90 again, and then 2 statistics, yeah. The O class, I talked a little bit about last time. It's a response to the state's requirements for us to put more students into transfer level courses. So we've tried to develop a way to identify students who might need more support to make it through a high level course, and we tell them they should take a support course. That's the O course.
I heard about that. I told them.
For which classes? For which level?
We'll see.
For which level?
I have no problem with the idea of providing more support for students. I have a problem with not letting it be for anybody who wants it, only allowing certain students to get it, and maybe putting students into higher level courses before they're maybe ready for it. So I have issues with things around it. Yes.
Well, it's hard with tutoring. You can never get a schedule.
I know.
If you do, it's during your class.
So they cut our budget for tutoring and they give us a little closet. Priorities are out of whack.
So where's all the money going then?
Huh?
Where's all the money going? Towards like sports and stuff?
It's going to appropriate places.
To make overs.
To make what?
Make overs. Not of the teachers.
Thanks. Hey, Anna's like, as you can tell, it's not for makeovers of teachers. Thank you for that. That made me feel so good.
No more parking.
Makes it easy to me.
All right, guys. So I'm ready, Spencer. What you got?
I don't know. I thought this one. I was kind of stuck on this one. Maybe it's prime. I'm not sure. But it's 49b squared minus 36a squared.
49b squared.
It's minus. But after yesterday,
It sounds like a good candidate for squares, right?
b squared.
Which problem was this?
It's 49b squared.
Do you remember what number it is?
288 on 7.5.
Is it this, you said?
Yeah. But I feel like we did that yesterday in class, so one night.
We didn't do exactly that problem, but we did that problem.
Yeah. And I think that's why I didn't do it on my homework, because
Can you cut everything in half?
Yeah.
Is there a minus?
Yeah.
So it is a difference of squares. So,
7 and 6.
yeah. So 49, 7, 7, 36, 6, 6, and then you got b squared, so you put b, a,
Plus minus.
plus minus, or minus plus, doesn't matter.
Why was that so difficult?
Okay, so you said you can only do that when it's minus?
And I really, now watch. Why does this work? Because don't I get 42 AB? Oh shit! But then I get minus 42 AB. The only way that could possibly work is if these are opposite signs, and if these are opposite signs, that has to be a minus.
Okay.
But if it's positive, then it would just be.
Yeah, so if I had, what do you got, 4x squared plus 25y squared, I'm screwed.
Yeah.
If it was a minus, it
Then
would
we're
work,
right, so
so
it
it
makes
makes
me
me cut
cry.
half, but it's a plus, I can't factor that.
We're probably not gonna get.
Because watch, if you thought it was this, 2x plus 5y, 2x plus 5y, right?
Yeah.
Why is that bad? Because it's 10xy plus 10xy, I'm supposed to have 20xy. Do I?
No.
So there's no way that this equals this, because it doesn't have 20xy.
There's no solution to that problem?
Yeah,
then?
no solution.
Okay.
I mean, not no solution, no solution would mean it's an equation. So it's not an equation, so the answer would just be
Prime.
prime. Yeah.
Prime.
It's just like prime. Then there was another one that was
Sing with
the
the
vehicle
chorus.
mound. It was 294, and it's 64x squared
64x squared
plus 16xy
plus 16xy
plus y squared.
plus y squared. This one's kind of neat. It seems like it's going to be horrible because that's frickin' 64, right? Yeah, but doesn't it jump out at you 8 and 8? What is about 8 plus 8? Yeah, so notice, what if I turn this around? What if I made this x squared plus 16xy plus 64y squared? Then it's 8 and 8, all right, right?
Right.
So instead of the 1 being here, they put the 1 there. Tricky.
So it's the same thing.
Oh. Yeah, so it's really the same idea. So it's 8x plus y, 8x plus y. Now watch, you could do this. To really see this, I can just aren't these the same?
Right. Yeah.
Unlike what I did a second ago, these are actually the same problem. Now it's got a 1 out front. Right, so how will this work? Y squared is y, 64x squared, 8x, 8x. And these both have to be pluses.
Okay. For some reason, I was like, oh, here's coming back to 4x squared plus xy plus y squared. Made no sense. I don't know why I did
Oh!
that. Yeah, I tried, because I was like, oh, cool, they'll
But not this guy.
not that guy. No.
If you think
So
it's
then
GCF, you have to be able to multiply back in and give right back to where you were.
Right.
And that guy's got no numbers to give.
Yeah. Alright, thanks.
Sure. Notice this. See, if it was that's the sum of squares, it wouldn't work, right? You see that? Y squared plus 64x squared. Sum of squares. Doesn't work. Why does this one work? Because it actually has that middle term that it would need. This one didn't work because it didn't have the middle term it would need.
Another question. Yes. 25x squared
25x squared
plus 35xy
plus 35
xy plus 49 y squared.
49
Y squared.
y squared. This one's kind of neat. In fact, you could still do this 25 times 49. Well, first off, do you see any GCF? Shit, no. That only has 7. 7 goes into 35, but shit. Got excited for a second. Oh. So you could do 25 times 49. Do you want to? No. So here's a little thing. Notice that 25 and 49 are actually squares, right?
Yeah.
This isn't a difference of squares or something because there's freaking 3 terms. Are you guys with me? But notice if I try 5x and 5x, what would I put here? 7y, 7y. I'm not guaranteed this is the answer. What do I have to check? What do I get by doing that? I get this and I get this. So obviously I have to check to make sure that I get the middle. So 35xy and 35xy is too much. Right? That would be 70. That would need to be there. So that doesn't work. That's evil.
So we do have to do 25.
Yeah, but then you'll see really quickly that it ain't gonna work. So if you do 25 times 49,
1,200.
I want you to realize it doesn't matter what that is, because I can play around with the parts, right?
Yep.
And somehow I'm supposed to get 35 if I rearrange that. Well, here's the 35 and the 35 that we got just a second ago, right? All right, that didn't work. The best I could do would be like 5 times this, right? Which is 240. You could do it, Jeff. I don't know, 245, I think. That's what that is. And 245 plus 5 isn't gonna matter. All right, so this is freaky. So what I'm doing is 25 times 49. There it is. But I'm gonna play around with the factors, and there's no way in hell I'm gonna get something from here that's gonna add up to be 35. There's just no way.
245.
Yeah, 245. So I was right. Yay! Good job. So it could be 5 times 245. I don't know if you guys are really with me when I say this kind of thing. Yeah, what did you say 25 times 49 was?
1,225.
Okay. So you could kind of try to break that up, but what I'm saying is, here's what it breaks all the way down to be. Then I can recombine. There's 35 and 35. There's 245 times 5. What about 7 times this? And that would be 175, right? Maybe 175 times 7. Can that make 35? No. So I mean, this ain't gonna work.
Supply.
It could be a typo. What I'm thinking is a typo. I think they meant to put a 70 there, but they made a mistake. And the way they've written it, it is prime.
Idiots.
So that would just be a prime.
That's a prime, yeah, well, in fact, yeah. Alright, maybe. But, the first thing you try when you see a problem like this, what do you got, Jeff? I don't know, man. Alright, let's see if I can, I don't trust myself now. I can't think. Oh, yeah. Alright. Yeah, I think it's 80. Let's see what happens. Let's see if Jeff got this right. So, first thing I would try if I saw this, notice how these are squares, right? So if I put 8x, or 64x squared, 25 is 5 and 5, right? And everything's positive, so let's check the middle term, 40x plus 40x. So I'm done.
No?
Why?
What did you say?
What's 40x plus 40x? 80x.
And you said no.
And I said, no, I didn't say no.
Oh,
Why would I say no? That's beautiful.
I don't know.
I don't know what I said. I'll have to go to the tape.
No.
I'll have to go to the tape later.
You just worked out.
Come on.
I believe it. It's like you the answer.
If this and this are squares, this is the first thing I'll try. Notice that's what we tried there, right? And it didn't work, so what did I do then? I had to do it the way, yeah. So, but I'm gonna try that first, and if it works, I'm done. So there's a decent number that will work like that. And again, I think they really did make a typo, but the way they wrote it, it's prime. Too bad for them.
Thank you.
Okay.
You should write on the test where all the problems are prime. I think that would be really cool and interesting.
Too bad.
No, it'd be, you could make us do all the steps and then we'll find out.
You want me to make every problem prime? Is that what you're saying?
Yes.
Yes. And then have the bonus question is like really big, problems.
God, you guys are more evil than I. All right. Anything else for homework stuff before we get back where we left off?
Where'd we leave off?
I'm gonna remember as I turn around
It was A cubed.
and raise my marker. Oh, yeah, we did. We can do some more cubes again. It's up to you. It's question time. I'm gonna get into the last section we haven't done yet. If there's no more questions.
Ask questions.
What about 10 m to the fourth minus 6,250?
Say it again.
Minus 6,250.
All right, that one's easy.
Yeah, for sure.
I put, this is what I got, 10, took out a 10.
Good. Okay, you can't do shit until you do that. I'm sorry, Spence. I didn't mean to make it sound like that. It's amazing. You did the right thing.
I'm just asking.
You always try GCF first, because either it's the only thing you can do, or it makes what's left over easier to do, because that's a lot better than frickin' 6,200.
Oh yeah, that would make sense, because the zero.
How many terms are there in here?
Two.
So it can only be, what, two things? Either squares or cubes, right? Is it cubes?
No.
Hell no. So it can only be squares. That's obviously can be cut in half. That one's the one that's weird.
That would be kind
You just gotta think about,
Is it 25?
it's 25.
of, it's 25.
I'm so sorry.
But, I mean, so what do you do when you hit this? So you're gonna have calculators you can use. You can take the square root of this, right? Because you know this can be cut in half, so then if you square root that, you can see if that can be cut in half. If it can't be, you're done. It was only GCF, but you know it should be. So 625 is 25 times 25. M to the fourth is m squared times n squared. So now you should be able to write the second to last step. There's two more steps after this.
Is this a plus, like m plus 5 times f minus 5?
Not quite.
Because it's got a
So again, M4, so what do I put?
M squared.
M squared. 12 minus 25 plus 25.
And it's not done, right? You're not done. Well, you're not done.
You're not done.
Because it's different.
Because you can
do
shoot
it.
Shrink it even further?
Not shrink it, but expand it, right? Because
Yeah.
what can you do with this piece?
You can,
Isn't that a difference of squares?
Yeah.
So you gotta let go of where you came from. This is a brand new problem now. And you gotta go 10, I can't do shit with that really, I can't do shit with that. This one though,
10 plus 5 as and
alright, and so basically to the problem for it, you can finish it out though. Maybe pretend like you're doing something with that problem.
And then is there anything we can do with the second parentheses, boy?
Why can't you?
Because it's a sum square.
Some, yeah, some squares you can't do.
could you do an equation similar to that one?
Okay.
So I can understand the
So
import.
10 times n
Because I
plus
know you
5
don't like
times
doing
x
whole
minus 5 times.
Well,
n
basically it
squared
is
plus
not fun,
25.
but, let's see.
Yes.
I don't know. See, I stopped it.
What was I just thinking?
That's why.
So what if I had,
I got 10 times n plus 5 times n minus 5 times n squared plus 25. The
minus,
second parentheses is sum of squares, and you can't do shit with that.
fullness.
Wait.
Yeah.
Yes,
Yeah.
I wanna leave at least one step for home.
Wait, I don't like these erasers. Give me this
Oh,
one.
is that home?
I'm gonna
No,
finish
give me
this
the
one.
one back.
That's right. Guys, what about this one?
Same thing.
Yeah, take out the 8.
Take out the 8.
And then that's 81?
Good, 81.
Didn't expect to get that right.
I like how you randomly said that.
Because it's the 64 and the 8. Yeah.
I like that.
The
That's
scales.
cool. Yes.
Start cackling like a witch.
Excellent. Good news, everyone. So, what can you do with this here?
Hang on, I'm not done.
Yeah,
writing down the first part of the
y2,
problem.
81,
And then,
I9,
minus plus.
9.
Yeah, and then the first parenthesis boy you can expand further, factor it out. Yeah, parenthesis boy.
This guy comes
You want to
down.
give him a name? You want to call him Todd Spencer?
Todd.
Yeah, no. Okay, let's go with what Spencer said. So you can factor out Todd. I'm flaming my friend. Don't worry about it.
I'm just messing
So
with
this
the
guy, so again, anytime you do something factoring, you gotta look at each piece you just created and see if anything can go further. Sum of squares, it just goes for the right. 8 comes for the right. This guy, yeah. Can't you cut everything in half?
Why?
Why? Why?
Minus
3.
3.
Okay,
Okay.
I get enough.
I like it.
So you pretty much just take that one and you have to split it again, basically.
Yeah, so anytime you take a step, whatever it is you just did, you gotta look through everything you just got and see if anybody can go further, every time.
I concentrate on
So how do you
certain
like with
method
the
and
primes?
too many out of
How do you know when it's
Sorry.
prime versus when you just
Huh?
forgot all the rest of the options?
This one, right?
That's what I'm testing.
Okay.
That's, you gotta figure that out.
Dang.
Yeah. Alright,
But you're not testing this now.
moving on. Okay. I kinda gave you a preview of what factoring can do for us. I made like a ratio of expressions and we factor, just to remind you guys. Here's one little thing we're gonna do in the future. Using this idea, you could do it, Jeff. Can you do it? Yes, you can. There you
And
go. Ew! Why can't I cancel the x squares?
because they're doing
three.
stuff.
They're doing stuff.
Yeah.
Division is not the opposite of subtraction or addition.
Yeah.
But if I rewrite this and this as multiplications of things, then division can do its job. It can kill shit. Right? Division's job is to kill parts of multiplication. So what can I do at the top here?
X times X.
Yeah, xx minus 3 plus 3, right?
Well,
Become a thingamajig. There you go. What can I do at the bottom?
12, 6.
No, 6 and 2 would make 4, not 1.
That's
So 12 is
3 and 4.
3 and 4.
3 and 4. And which one's gotta be negative?
3.
3, the smaller one, so then it comes out positive. And then who dies?
3.
X minus 3. I don't see any 3 in there. Alright, is that cool?
Yeah,
So that's one little thing. That's actually in our future, but once we know how to factor, you can immediately do this. So I'd like to show you
And
this.
you would just add and you would just combine the X plus 3 and the X.
How would you combine them? Because they are dividing, right?
Oh,
That's
yeah,
just
yeah,
the
that's
answer?
what I meant, is like,
That's the
how would
answer.
you, yeah, how would you?
That's it?
format
That's the
that?
answer?
Okay.
Yeah, can't reduce any further.
Okay.
So this is simplifying fractions. I mean, how do I simplify fractions normally? What's 9 over 12? How would I simplify that? Well, 9 is 3 times 3. 12 is 3 times 4.
You take the 3.
Do we ever write it this way? No, because we can do this sort of in our head, right? But can I do this in my head? Not so well. So then I write it out for myself because I'm not as used to working with expressions as I am with numbers. But do you see how it's exactly the same process?
I really wish you were my arithmetic teacher.
I'm sorry.
Because I literally,
and everything.
like I literally understand, oh, sorry.
The X squared plus X. Why is there an X?
Careful,
there
careful.
at all?
No. This is the problem that was given to me.
Oh,
Yeah, that's all. So since
so what
this,
do you do with that extra X in the middle?
no extra x, it's not an extra x. If I have three terms,
Okay,
I need to find two numbers that multiply to be negative 12
yeah.
and add to be 1. So when we learn two-term stuff, it doesn't mean everything we learned before is gone. It just adds to what we know before. 3 terms still exist. We know how to factor them. Now we also know how to factor 2 terms, squares, cubes. Add that to the list of things. Don't overwrite. Yes?
What sections is the quiz gonna be on?
Oh, it's gonna, everything up to 7.5, I think. So it's gonna go through cubes. It's gonna be every factoring formula we've learned so far. It's gonna be so much fun.
I love your sarcasm.
Yeah. You better. All right. You better say so. I don't know.
So, how
Yes.
do you know when to do the cute thing, the little thing, and then the big thing?
So
How
what do you do? What do you do?
know
You
when-
always try what first?
Greatest common factor.
GCF. Once you've tried that, if it worked or didn't, what do you look at next?
How many terms?
How many terms there are? If there's 4 or more, you're gonna group. If there's 3,
Trial and error.
either trial and error or surefire. I love that.
You're cheating.
He's-
He's reading it off the word page.
I'm not wrong.
I couldn't tell. Yeah, he wasn't looking at me, so I kind of knew that.
This.
2 terms would be what or what? We just talked about it.
Yeah, tell him, Spencer.
It's the 2 or 3. Cube or
There it is.
Square.
All right, now, come on, come back to me. You guys understand what I'm saying? So it's really nice that the number of terms tells you what method to try. It could be prime, but the number of terms tells you what method should work if it is factorable. You guys see, always try GCF first. Because either it's the only thing you can do, or it makes what's left easier to do, right? And then just count the number of terms.
So the cube thing is when you have 2 terms?
Yes, so when you identify you have 2 terms, you go, it could be squares or cubes, then you just say, can I cut everything in half, or can I cut everything in thirds?
Okay.
So that's when you have to know. The better you know, and if you haven't done this for yourself, what's 1 cubed? 1, that's amazing, Jeff. What's 2 cubed? 8. What's 3 cubed? 27. 3 times 3, 3 cubed. 4 cubed? 64. 5 cubed? Yeah, the road that gets us here. Even 6 cubed, maybe that's pushing it. I don't know. 216, all right. And that's maybe as far as you gotta go. So we see those numbers show up. When I make a cubes up on the board, I go to these numbers because they're the numbers that'll work. They're the numbers that can cut into 3 parts. So if you see these numbers, you know it's a cube. And square numbers, you should know even better. You know your square numbers. They should kind of jump at you. And you look at the exponents too. If there's a 5th power, it's screwed. I can't cut that in half or cut that in thirds. But if it's a 4th power, I can cut that in half.
So anything you can cut in half evenly is.
So if it's 2 terms, I can cut everything in half evenly. It could be a square. It's got to be minus in the middle, right?
Yeah.
So I don't care how big I make it. What you got, Jeff? There you go, buddy. It's just that first step that's hard.
That's pretty good.
Ooh, I like it. Yummy, yummy. I always think about Yoda in this case because just to show off my true geekiness, Star Wars, and Luke is trying to lift his X-wing fighter, and Yoda comes out there and says, "Size matters not." And there's a lot of shit in here. So if I put this instead, people would say, "Well, that's easier," and I would say, "No. These are both the same exact problem. I can cut everything in half here. That one's just got more shit I gotta write, but it's still just writing some more stuff. Who cares?" Right? So how would this work? Well, it's the difference. There's two terms, no GCF, and can I cut everything in half? Multiplicatively, yes. Not 50-50, right?
No.
This is all about factoring, which is all about multiplication. I gotta cut it in half multiplicatively. What's that gonna be? 10, x4, y 7, x4, y 7. So half and half together make a whole, minus plus or plus minus 7, a5, b 250. I don't let the 500th power trouble me because my only deal with it is to cut it in half. That's all I gotta do to it. Who cares? So don't go 500th power. What the shit do you think I am, Joe? I don't care. You can cut 500 in half. Shit. You guys see what I'm saying? So it's identifying what form it's in. The minute you know it's a squares, you should kind of go under your breath, thank your favorite deity, whatever that might be. Flying spaghetti monster, the god of coffee, one of your traditional gods, whatever the hell you like. Right?
Everything in half.
Huh? God of math, maybe?
You know math is a godless subject.
There's a god of math.
It's the god of math.
You gotta make the appropriate sacrifice before it tests. And your sacrifice is not a math teacher, huh?
The gods of convenience.
Gods of convenience, so that'll work, right? All right, so, is that all right? Okay. We gotta do this before I let you out of here. What time is it? Okay, we got time. All right, this is 7-6. Let me ask you this. This is gonna sound kind of weird, but if I knew two numbers, so let's just say I know two numbers multiplied to be 20. How could I represent that mathematically? I know two numbers multiplied to be 20. Don't start listing off answers. Just represent that idea mathematically. Do you know either of the numbers?
4 and 5.
Do you know that they're 4 and 5? No.
No.
So let me ask this again. Do you know either of the numbers?
No.
No. So what's one number? X. What's the other number?
H.
One.
I like H. Y. And so I know X times Y is
XY.
20. That's all I know.
Oh,
Yes,
that's
you're,
okay.
yeah, you're right. Can't say that's wrong. That's right. But that's the complete equation. And one possible answer is 4 and 5. Another one is 5 and 4. Another one's 20 and 1. Another one's 40 and 1/2. Another one is 400 and 1/20. Another one is square root of 20 and square root of 20. Oh shit, yes.
2 and 10.
Right? How many answers are there to this? Infinite number. Okay, so that's not good. Is there a better number to put here so I actually do know something about one of these?
19.
19 would suck even worse because then it's 19 and 1, or the square root of 19 and the square root of 19, or, yeah. 3 times 19 thirds. I mean, there's still an infinite number. So here's the answer. There is one number here where I would know something about these, and that would be 0. The only way two numbers can multiply to be 0 is if one of them is 0. So then I can write answers. Either x is 0 or
Y.
y is 0. Those are answers. This shit, I don't get no answers. I also don't get no grammatical help.
You might suck at each other.
Satisfactory answers to my equation. All right, so what does this have to do with factoring? That's a great question. You're like,
Oh, Jeff, I have a question.
Sure.
What does this have to do with factoring?
oh my god.
Good job.
You got them all track. Got you, Jeff. Don't worry about it.
This is the same thing we just talked about.
Mhm.
How many numbers are up here? 1, 2. What do? They multiply to be 0. So what must be true? Either the first number is 0, how would I write that?
X plus Y.
Either x plus 4 is 0,
That's 4.
or
X
minus
minus
zero.
X equals zero.
Let me let you, so that's the same thing as xy equals 0, x is 0, y 0. This is the first number, this is the second number.
With any variable, you can do that.
Yeah. Any two numbers that multiply to be 0, one of them has to be 0. So either, and this is a 4 here, right? Not 1. How do I solve this? So now I got two little equations to solve. How do I solve this?
X
X is -4, or
plus
x is 7. Right? And sure enough, you put a -4 in, this part is 0 times who gives a shit. If you put a 7 in, this part is 0 times who gives a shit. Right? I never said they both had to be 0 at the same time. Just one of them has to be 0. So both of these answers make this a true equation. Why does it make sense that I get two answers? Because what's the degree of the problem? Well, here's where things get interesting. What do you get when you multiply this out? You get x squared minus 7 plus 4, so minus 3x minus 28. So that would be where the problem would start. So what's the first thing we would do? Factor it, because then I can use this property we just figured out. This is what's called the zero product property. If the product is 0, there's a property of that lets me figure out possible solutions. Right? Why does it make sense there's two of them? Because the degree of that is 2. There's actually something called the fundamental theorem of algebra. If I have an equation where the maximum degree is 3, I can expect at most 3 solutions. And to be honest, I can expect exactly 3 solutions. It's just that some of them are types of numbers we haven't learned yet. Possible. Oh, baby. So let's try another one. So what if I had this? X squared, what do you got, Jeff? You can do it, buddy. There it is. There's the one that'll work. Okay. What would you have to do first? The mistake people make is they either solve for x, but then won't you have x on both sides? You can't, so there's no way we have to solve this until we learned this property. So effectively, look what I'm doing. I'm taking it from one second degree equation. I'm going to make 2 first degree equations out of it. That really is what this does. So first thing I do is I factor this. And how do I factor that?
-6
Yeah, -6
plus
positive 4. And then either x minus 6 is 0 or x plus 4 is 0, right?
Yeah.
So then I get x is
0.
6
6
Ah.
or,
-4.
yeah, you just have to actually solve those two little equations. They're going to be nice little linear equations. So let's try. If I put a 6 in, what do I get? 36